Hey, welcome back to my channel and welcome to chapter 10 of the Cross Origin Resource Sharing course. In this chapter, we're going to talk about credentialed requests and understand a few concepts that are key to it and look at a few demos to just practice out the concepts we'll have discussed. So to start it off, we're going to first define credentialed requests. We'll define credentials and then give a certain some examples to drive the point home. So a credentialed request, simply put, is any HTTP request or or response that contains credentials in the headers. So the credentials could be sent in the response or it could be sent in the request. Either way, it makes it a credentialed request. So this should probably be called a credentialed communication between the server and the client. So what exactly is a credential? A credential is any piece of data, in this case transferred over headers, that should be kept secret or it is privileged in a way that anyone that possesses it may be able to undertake actions that are only reserved for some people or a specific user. So this is why they are treated as credentialed because it is assigned or it is attached to someone specific and it should not be used by another person. So if that other person gets access to this credential, like what happens with passwords, then they can do privileged actions on the server, like stealing data or making changes, making bank transfers and all. So this is the area of credentialed requests that we're talking about, and some examples of credentialed requests, most common is cookies. The cookie header is basically a header that is stored on it is a header sent in a request to the server. However, it contains data that has been stored in the browser local cache or browser storage that is sent along with request to a certain server from which it was got. So a cookie is the most common type because it is um, it is used very widely across the web, and most of you may have seen this, if not in practice, or at least when you're using other people's websites, you should have seen, requests to allow cookies to improve your experience. So that is basically the most common type, but I want to clear some other misconception we've been having, including myself, about the authorization header. So when you do basic authentication or JWT authentication with Auth2 or any of a wide array of authentication mechanisms, usually you send an authorization header in the request. And this header gives you some privileges on the server. Perhaps it sets your username and password in a base 64 encoded text, or it sets a bearer token in the request header, such that the server is able to recognize you and give you such privileges. So I used to think that the authorization header is, well, it's a credential, but I used to think it is one of those that is governed by the cross origin resource sharing spec. But I've come to realize that it is actually not. So we in this particular chapter, we are going to discuss mostly to do with cookie header and not authorization header. We shall also demo the reason why I believe, or I've now come to learn, that authorization header is not credentialed as regards cross-origin resource sharing. And the reason for that is that there is a concept of browser managed and client managed or developer managed credentials. So cookies are browser managed credentials. Other types of credentials that apply in this cross origin resource sharing spec are like SSL certificates and a few other types of credential information that are strictly managed by the browser. That means that it's the browser that sets them in the request, just like it sets other default headers in any HTTP request. It will add cookies if it received some from the server to improve the user experience. However, if you compare that to authorization header is developer managed or script managed or client managed, depending on how you look at it. So authorization header is not something that is going to be treated in a special way by the course specification, because it is executed by the browser, and the browser applies this to only credentials managed by itself. So I just wanted to make that clear. We are going to see it more clearly in the examples I give. But if you go all over developer media, on Stack Overflow, or in different forums, you'll find lots of questions that talk about authorization header, in the same tone with credentialed requests in cross-origin resource sharing. But that confusion being rampant doesn't make it true, and it is just simply not correct that authorization header is considered a credential in the cross-origin resource sharing, simply because it is not browser managed, but it is developer managed. So I hope that is clear. So the next thing we're going to discuss is about the risk of. We've already talked about how credentials they give privileged access to whoever possesses them. So I want to talk about session riding. So I've talked about this before, but session riding is um, an attack mechanism used by malicious scripts. Uh, they take advantage of a certain browser feature where a browser is mandated to include cookies or credentials. And so I'm going to be using the word cookies from this point on. So a browser is mandated to include cookies received from a server and stored in its cache. So let me just put this again. Basically, when a script sends a request to the server and the server makes it sends back a response, many times the server sets a cookie in the response, which recognizes this particular user's session. And on the browser caches this particular session ID. And in the future requests from the same script or from the same origin, the browser includes this session information in a cookie back to the server, so that the server can know this request is coming from a returning user from the same session. So this is the aspect of session riding is used by malicious scripts that take advantage of the fact that if a browser has already got a response from server A, then the next time the same origin sends a request to this server A, then the browser adds the cookie, the session information in the cookies automatically. So a malicious script is going to embed its own request through the browser, such that the browser is tricked into including privileged information that the script can use to take advantage of the server, maybe steal user data or make bank transfers. There's so many ways of malicing a server or a user based on this session riding technique. So that is the aspect of risk that cross-origin calls put the server under, especially where cookies and credentials are involved. So now that we've seen the risk, how does cross-origin resource sharing protect from that risk, particularly from the perspective of credentials? So by default, browsers do not send credentials in the request. This is the default behavior, and this is an extreme position taken by the browser such that it doesn't expose user data, or it doesn't allow this session riding attack to happen. So the moment you try to send requests from cross-origin scripts, you will realize that cookies are not added into the HTTP request as they should. And if you want to go ahead to add these cookies, then your script has to explicitly request to send a credentialed request. And this is configurable. We're going to look at it in the demo section. And if the script has explicitly requested, then the browser will know, okay, you've requested to include credentials, but I need to know if the server accepts. So the server also explicitly has to accept that, okay, this request from these origins is allowed to include credentials. And this is usually based on configuration done by the developer on the server side. Again, we're going to look at that. And then the third thing the browser and the core specification does to protect user data is okay. That was the third. The third thing was The first was default mode. Browsers don't send cookies in cross-origin requests. The second is the browser has to explicitly request to include, the script has to explicitly request to include the cookies. Then the third point is that the server has to explicitly accept. So basically, this set of rules makes the inclusion of credentials an active decision instead of a passive default that can be manipulated. So the fact that it's an active decision is a very safe place to be for user data. And when it comes to simple requests, so we already saw simple and credentialed and pre-flighted requests in depth, but when it comes to simple requests, then the browser will go ahead and include credentials if you've requested for them without first asking the server. However, depending on the response from the server response will contain appropriate headers, but if the header called access control allow credentials is not included in the response, then the browser will reject the response from the request, such that your script will not be able to access it. So that is a fallback position just in case the server is not configured. But if the server is configured, then the value of access control allow credentials should be true. And if the value is true, then the browser will know that, okay, I already sent this request, but when the server responded, it allowed credentialed requests. So I'll allow the response to be exposed to the client script. And for pre-flighted requests, this is easy because then the browser already sends a pre-flight request to ask for the server's policy around credentialed request. And then it will read the header, access control allow credentials, and decide whether to send the actual request or not. And it will give an appropriate result or error based on that. So now that we've recapped the meaning of credentialed requests and credentials, the role of the server and the browser and the script, let's go into the demos. As I've done before, I have a list of items, a list of tests I'm going to run. But don't worry, even if I'm not displaying them, I'm going to first read the test, and then we discuss the expected behavior and go ahead and demo and hopefully see that behavior. And so basically, let's get started with that. So the first test I want to do is the one in basic setup, as we've seen before. As you can see here, the client is simply set up in a very basic way, as we did before, a simple request during an effect at the beginning. And then the response we receive from the server is set in a state variable, and then it is rendered in the body of the React component. So this is basically what we're going to continue doing. And we've not added the header we've added is content type and it's text plain. So this is going to just trigger a simple request. You can even remove it and it won't make any difference. And then we are going to send that request. What we really want to see, the hypothesis we want to prove is that cookie information is not shared by default. All right. So let me just, I hope you remember how the server was set up. We have the cross origin annotation without any parameters. So that means that it works in default mode. But remember, the default mode is to not include credentials. We mentioned this sometime earlier. So I'm going to save this so that a request is triggered. Yeah, here is our request. The request is working well. Our text is displayed here, but we need to pay attention to the request headers. So if you look through these request headers, there is no cookie header. Okay. Now I know this might not really make perfect sense because we've never talked about the cookie header, and we saw comparing something that is not there to a situation where we are explaining why it's not there may not be very intuitive. However, we're going to see situations where the cookie header is included. But I just wanted to show that by default, the browser will not include the cookie header because it's credential. It's a credential. So if you look at the response headers, there is also no, there's only access control our origin header. So this is just the basic setup. And indeed, if you depend on the cookie, then you're going to find that your cookies are not sent in the request. And without an understanding of cross-origin resource sharing, you may not even know where to start. But if you Google why are my cookies not included in my request, then you're going to find most of the results have to do with CORS. So this is the default behavior. And what I'm going to do next is I want to digress a bit and discuss the other aspect of authorization header. I want us to clear that out in practice so that it makes perfect sense. I want to make my case is that authorization header is not treated as a credential in cross-origin resource sharing specification. So let's just do that. I'm going to add an authorization header those that followed the video in chapter 8 about uh, simple and pre-flighted requests, where we started with request headers, you're probably familiar with what we're going to do. But let me just make it clear. Let me repeat it so that we keep our knowledge up to date for this video. So authorization, let me assume it's like that, and then I save it. Basically, if you look at the request that has been sent, you'll see that in the request there is just look at the request headers. Okay, so I expect authorization header to be here. So there is a pre-flight request. Okay, of course, when you add a custom header, there is going to be a pre-flight request. So let's look at the pre-flight request. I thought I had clicked the actual request. So access control allow headers is added because the browser has encountered a custom header that is not considered course safe listed. So let's see the response to the yes, access control allow methods, access control allow origin, but there's access control allow headers, which is authorization. So it has been allowed, and the request proceeds normally. And when it proceeds, then it adds the authorization header in the request that goes to the server. So basically, I want us so I want us to disable CORS and see that no, in fact, let's not go to disabling course. The point I want to make is that authorization header is only treated as a custom header, not as a credential. And how we test that hypothesis is one, the browser doesn't by default include credentials in the request. So when we set an authorization header, the browser includes it simply because it is a client managed credential. It is not a browser managed credential. Okay. So this allowance we experienced here for the authorization header to go is because in default mode, Spring Boot sets CORS configuration to be very lax. So let's try and change allowed headers to some value that is different from authorization, and you're going to see that it is not going to be allowed. So I'm going to so cross course the pre-flight has failed. Reason for it to fail, as you can see, is not very specific. We talked about this in detail. However, the fact that the request has just not been sent because of that failed pre-flight request does not help us understand about credentials, because here basically the reason is that this is a custom header, not because it is a credential. So again, we can revise the case where our authorization header is among the allowed headers. Then you'll see the request going through. And when it failed to go through, the error message wasn't that this is a credential. No. But I want to trigger the error message where okay, Just a moment. I started the server twice. Okay, so in fact, I got a bit confused, but the everything happening here is expected, but the point I'm trying to make is what is getting a bit lost, but I'll just reiterate it. Authorization header is not a credential. It is a custom header according to the browser when it comes to CORS. So when we include it, even if we've allowed it on the server, the reason it is included is not because we've set up any credentials. Remember, we have to the script has to explicitly request to include credentials. And for authorization header, it simply doesn't. And sometimes people see the authorization header disappearing from the request and they think it's because of course credentials. But no, it's because it is a custom header. So I want to just go up to that point where the browser tells us that uh, tells us why the authorization header is not allowed. So what I've done here is to include the specific header, and I want us to see success. I've included authorization among the allowed headers. I want us to see success. So now pre-flight has passed and the request has been sent successfully. So if I add custom header in the request here, I just want the pre-flight request to not fail with the forbidden error. So if you followed the previous video, you'll know. If you follow the previous video, you will know the situation where the request is rejected by the server and the one where the server sends the headers and the browser will be the one to reject. So I want to set this particular header here such that we have one allowed header and one rejected header, and the rejected header will be authorization. Okay. Yeah, we're back on track. Really, I don't think we even got off track, but I was a little confused there. And so now, custom header, we have one header that is allowed, and we have another one, the authorization header, that is not allowed. Let's see what the browser says. Let's start that request. So here we can see that the options request has failed. And right, so let's just pay attention to this because this is going to be some bit of debugging now. I didn't expect it to fail with forbidden, and the error is still no access control allow origin. Did I restart the server? Okay, let me restart it again just to be sure. Come here. Oh, I didn't save the request. I didn't save the changes in the script. So let me save them, and you can see down here. Okay, let me remove everything and trigger it afresh. Okay, so you can see pre-flight request is successful. As I said, the request headers is X header custom and authorization, but the allowed header is only X header custom. So the options request returns with a valid status 200. It has not rejected the request outright. So let's go to the console and see for ourselves the reason why the request was blocked. So access to fetch at this from origin. This has been blocked by CORS policy. Request header field authorization is not allowed by access control allow headers in pre-flight response. So I just wanted to make this distinction clear that the fact that authorization header was not accepted is not because it is a credential, but rather it's because it's a custom header which has not been allowed by the server. And even to make that clearer, to make that clearer, let me run another test whereby I want to. So assume I'm a developer who comes across this error and I don't really understand what's happening, but I read from the console. I removed it, but we can just do that again. I read from the console that if I want the request to proceed, in this case, it has not displayed set mode no course, but let me try and do that. I remove this. So when I disable CORS on the browser side or in the script, then the authorization header, instead of the request being rejected, it will simply not be included in the request. So let me do no course. So this is effectively disabling authorization, CORS on the browser. So when I save that, no pre-flight request is sent. When we open the request and look at the request headers, we can see that sec fetch mode is no course, and origin is not set. Reason being we've disabled course, and basically the authorization header is not there. Even X custom header is not there. So all custom headers will not be included in the request. This is the browser's default mechanism in case you try to circumvent the rules by disabling CORS. So I hope that is clear. And now I want to we've now clarified about the authorization header, so we can remove this and remove the mode no course so that we get to compliance. We get back to compliance. Right, so back to a clean slate on the server side. Again, remove that. Back to a clean slate. So what I want to demo next is that we're now back to the aspect of cookies. So we've thrown away authorization header. It's not credential for our use and purposes. So we're going to focus on cookies now that we've discarded authorization. So I mentioned earlier that the script has to. I mentioned that by default the browser will exclude credentials. We've already seen in the earlier request that cookies were not included. Then we clarified about authorization header, but now we are going to see the next condition for course specification to protect user data when it comes to credentials. That condition is the script has to explicitly request to include credentials. So how we do that is with fetch, we can use credentials mode include. By default, the value is, so these are the options that you can set to this mod, this fetch attribute. So by default, it's same origin. So if you're sending your request between the same origins, it's okay, cookies will be included. But if you set omit, it means that they must always be removed, even if you're communicating between same origins. I don't know why you'd want to do this, but it happens. Maybe this is what happens when you reject cookies in the browser. I don't know. But what we're dealing with is include. It means that you're requesting the browser to always include credentials in the request to this server. So I'm going to set it as include. So we're not setting anything else because the credential we're targeting is the cookie, which is set by the browser by default. So I'm going to save that and see the request. So this is a simple request, and you can see there is a failure. If we open that failure, the status is 200. But I mentioned earlier what happens when you do this, and the status is 200. We've already requested credentials to be included, and this is a simple request. I talked about simple and pre-flighted requests just a few seconds back and described what happens when you include credentials in each of them. So in a simple request, let's see, we said that the browser will go ahead to execute the request. However, it will block access to the response. So we're seeing this response not because it was received from the server, but let's refresh it just to make sure everything is clear. So I will refresh it. So now you can see our response is not here. Okay. It was just a cached value that was displayed. The page wasn't rendered. So let's go back to the error. Status 200, but the response was blocked. Uh, and you can even see now we have a cookie header. This is key information to note. Before we didn't have it, but now we've mentioned credentials that include. We can even first disable it, and we try again. Save. Request goes through. Status 200, and it's not read, and the response comes through. We come here. There is no cookie in the request. You see that? So when I include, those are earlier errors. So when I include credentials, then you can see because of that change alone, it has turned to red. But the request was received with status 200. That means it passed successfully. However, access control checks after the request did not pass. We had added a cookie already in the request, but when the server responded, let's see the response headers. There's only allow origin. There is no credentials or there is no credentials header. So if you go to the console logs, what's the error? The value of access control allow origin header in the response must not be a wildcard. So this is another rule that we I think we've talked about before or sometime. Basically, when you want to include credentials, the first thing after the browser request for inclusion of credentials, the server has to make sure that it's not using a wildcard for the allowed origin. All right. There are some security risks when you use a wildcard value instead of a specific value. So the CORS policy does not allow to use credentials when you use a wildcard value. I've already talked about this before. So let's quickly first solve that issue. And that's because in default mode, Spring allows everything. So let's just add our specific origin so that we solve that hurdle and see the actual error of credentials. So this error, I think we've never seen before, but basically it is one reason. It's a very common error if you search on Stack Overflow, and the reason is basically that course specification that you can't have credentialed requests and wildcard origins at the same time. You must have specific origins before you're allowed to use credentials. So this is one rule you should keep in mind. It can save you a lot of time. But the good thing it's clear enough. So we are going to, since the server started, we're going to send the request again and see for ourselves. Okay, the request has now failed, but I'm very certain it's not for the same region of a wildcard origin because we've just solved that. It has failed. So now the allow origin is not a wildcard value, it's a specific value. So this is one step ahead. Our cookie is still in the request. This is good, but let's look at the console. On the console, the error is now the value of access control allow credentials header in the response is empty, which must be true when the request's credential mode is included. So basically what we've done is to request for inclusion of credentials on the browser. We encountered one hurdle where our access control allow origin header was a wildcard value. We've solved it. So now the browser still hasn't received a positive response from the server. So it can't allow our request our response to be processed. Remember, the request went successfully, but the response was rejected by the browser. Even the response tab here is empty. The reason it was rejected is because basically that is the way CORS and the browser protect the user data. So it's just assuming that this script of ours is a malicious script and we need to protect user data from it. That's why the data is not exposed to the script. So the browser has rejected this because the server did not that the server rejected the credential request, but rather the server did not say anything specific because from this error it says the access control allow credentials header and the response is empty. It needs to have a true value. I already talked about this in the theoretical section. So what are we going to do? Let's fix that hurdle again by let's fix that hurdle by adding that header, that configuration. So allow credentials. So now we set the value to true. We can't set it to false because then the browser will just tell us that the value is false. It should be true. Remember what the error said when we looked at it as the server is starting. Everything is clear. So this means that the change had to be made on the server. Remember, we finished the part of the client script requesting. Now we need to enable the server to allow before the credentials are before the request is sent successfully, and also the response processed successfully. So let's refresh this. So now we have success, called success. The request is a simple request, no pre-flight. So it's successful as before, but also additionally, we've now got a response. Reason being the server accepted. So if you look at the headers, you'll see the cookie is here. And then apart from access control allow origin, there's now access control allow credentials, and the value is true. So this is the condition under which the browser will see that the server has allowed us to include credentials. So then what else do I want to? So this is basically everything I needed to demo, but maybe we can just add a case for pre-flight. Remember, we've just been looking at simple requests, but let's try and make this a pre-flighted request. How do we do that? We can just include content type header and keep it to set it to JSON. This one will trigger a pre-flight request for the reasons you know very well by this time. So let me restart it. So there's a pre-flight request and a follow-up actual request, which is successful. So when you open the pre-flight request, you will see that the what was the browser asking the server to send. It shared the origin. It doesn't include credentials in the pre-flight request. Let's get that clear. Okay. So most importantly, the access control request headers is here. Basically, whatever the pre-flight request content is, the server will send the what it deems to be important headers in the response to guide the browser. So let's see the response headers. So allow origin, we've always seen it. It's the most basic course configuration and it's the only compulsory one for a pre-flight response. Max age, we already talked about that. Headers is here, but most importantly, access control allow credentials is there, and the value is true. And based on this, the browser goes ahead and sends the actual request. And if you look at the request, our cookie, which is the credential we're studying here, is included in the request. So that is it for our demo, and I think I've checked all the boxes necessary. And most likely, this is going to be the end of our theoretical and demo sessions for course from course usage in Spring Boot and React. So in the follow-up chapters, I'm mostly going to talk about now Spring Boot specific course topics like how to configure. We've mainly just been using cross-origin annotation. It's very flexible. We saw how to do it across different stages, like on methods themselves, on the controller level, but there's also global course configuration. So we're also going to look at options where there's Spring security and all this. So there are a lot of nuances, and we're also going to trace like exactly how Spring Boot processes course requests, right from the dispatcher servlet and all the way to sending the errors, managing the different headers. All this will be coming up in future videos. But for the purpose of the rest of the topics are really optional if you want to dig into the infrastructure aspect. But maybe just the next one where I talk about other global config options apart from cross origin. But beyond that, the rest of the topics are quite advanced and they're not really necessary for you to be a good course practitioner, I would say. So, with that being said, thank you very much for your attention and see you all in the next video. Cheers.